Let's look at area between the curves and solve our 18 problems. Let's look at the first one. Y is equal to 3 square root of x and y is equal to 2 square root of x. Now, first is we need to make sure that these two curves do not intersect each other. And here they would not, because this is 3 times and this is 2 times. Okay, and we want the area between these two curves in the interval 0 to 4. What we have to figure out next is which is higher, right? So if we are talking of these two curves, this goes like this and this goes like this. So this is 3 square root of x and this is 2 square root of x. And here we notice that 3 square root of x is higher than the second curve. So which means if we are interested in 0 to 4, this area, then first we figure out the area under the curve 3 square root of x, that is this entire thing. And then we figure out the area under the 2 square root of x. And then when we subtract these two, we get this. Okay, so let's begin. So area under y is equal to 3 square root of x. We know how to do that. So this would be a1 is equal to integral from 0 to 4 of 3 square root of x dx. This we can write it as 3 integral 0 to 4 of square root of x dx. Okay, now let's integrate 3 times x to the power of 1 by 2 plus 1 by 1 by 2 plus 1, 0 to 4. So we get 3 times x to the power of 3 by 2 by 3 by 2, which we can write it as 2 by 3. So this gives us 3 and 3 cancels, and remember this interval is there. 2 x to the power of 3 by 2 in the interval 0 to 4. And now we do the substitutions. So 4 to the power of 3 by 2 minus 0 to the power of 3 by 2, which gives us 2. Square root of 4 is 2, 2 cube is 8, which gives us 16. Okay. Now we figure out the area under y is equal to 2 square root of x. Okay, this was 3 square root of x, now 2 square root of x. So let's say a2 is equal to 2 integral 0 to 4 of square root of x dx. So 2 x to the power of 1 by 2 plus 1 is 3 by 2 by 3 by 2, which we can write it as 2 by 3, 0 to 4. Okay, so 2 times 2, so 4 by 3. And now we do the substitutions. 4 to the power of 3 by 2 minus 0 to the power of 3 by 2. This gives us 4 by 3 times square root of 4 is 2, 2 cube is 8, which gives us 32 by 3. Remember, we have to subtract these two areas. So area required is a1 minus a2, which is equal to 16 minus 32 by 3, which gives us 48 minus 32 by 3, which gives us 8 minus 2, 6, 4 minus 3, 1, 16 by square units. So that was our first problem. Now let's look at the second problem. Y is equal to 3 by x square and y is equal to minus 1. in the interval -2, -1. Remember, the first step was to figure out whether they intersect each other, right? For whatever be the value of x, y will always remain -1. Okay, and this will always be positive. This will always be negative. So that means this is higher than this. Okay, and they will not intersect. So area under y is equal to 3 by x square. Let's figure out this. So a1 is equal to integral -2 to -1 of 3 by x square dx, which is equal to 3 times uh, this would be -1 by x, -2 to -1. Now let's evaluate this. So 3 times -1 by -1 minus -1 by -2. So these two cancel out, these two cancel out. So we have 1 minus half, which gives us 3 times half, which is 3 by 2. That was our area under 3 by x square. Now we have second area to be evaluated. Let me write it down. So area under y is equal to -1 in the interval -2, -1. So a2 is equal to integral -2 to -1 of -1 dx. This would be minus x from -2 to -1, which gives us -1 minus x, not x, minus -2. Be careful of these signs. So this becomes -1 and this is 3 times minus is there, so -2. So that would be -1. So area required or required area is equal to a1 minus a2, which is equal to 3 by 2 minus, no, minus -1, which gives us 3 by 2 plus 1, which is 5 by 2 square units. To the third one, let's say f of x is equal to 2 by x square, very similar to the previous problem, and g of x is equal to -3. The only thing is the gap between these two curves is higher in the interval 1 comma 3. Again here 2 by x square is going to be always positive and this will always be negative, so which means that this is higher than this. Okay, so a1 is equal to integral 1 to 3 of 2 by x square dx, which gives us 2 times -1 by x 1 to 3, which gives us -2. And now let's do the substitutions. 1 by 3 minus 1 by 1, that is 1, since we have taken the minus sign out. So this becomes -2 times 1 by 3 minus 1 is -2 by 3, which gives us 4 by 3. Now let's look at the area under g of x equal to -3. So area 2 is going to be integral from 1 to 3 of -3 dx, which gives us -3, we can take it out, x from 1 to 3, which gives us -3, 3 minus 1, which gives us -3 times 2, which is -6. Okay, and the required area is equal to 4 by 3 minus -6, which gives us 4 by 3 plus 6, which is 4 plus 18 by 3, which is 22 by 3 square units. Let's look at the fourth one. This is going to be a little bit more complicated. So f of x is equal to minus x square by 2 minus x plus half, and g of x is equal to minus x by 2 plus 3. And the interval we are interested in is minus 5 minus 1. Okay. Now do they intersect each other? In the previous three examples, we could really make it out without doing any evaluations. Now we are not very sure of this. So let's figure out minus x square by 2 minus x plus half is equal to minus x by 2 plus 3. Okay, so minus x square by 2 minus x plus x by 2 plus half minus 3 equal to 0. Let's see whether we get any x values. Minus x square by 2 minus x by 2 minus 2 by 2 equal to 0. So 2 cancels, and we can actually take out the negative signs from each one of them. X square minus x, no, plus x, and then plus 2 equal to 0. Now if we use the quadratic formula, what do we get? Minus b plus or minus square root of b square minus 4 to 8 by 2a. Now this becomes a negative quantity, so which means imaginary numbers. So which means these two curves do not intersect each other. So that is one less thing to worry about. Okay, so now let's figure out the area 1. Okay, another thing that we have to figure out is which is higher. Okay, so to figure out that, pick any one value between minus 5 and minus 1. Which is higher? This is higher. From minus 5 to minus 1 of minus x square by 2 minus x plus half, which is equal to minus x cube by 3. 2 is already there, so 6 minus x square by 2 plus 1 by 2x in the interval minus 5 minus 1. Okay, so this would be minus 1 by 6 minus 1 by 2 minus 1 by 2. Okay, this is the first part, then minus the second part. So 125 by 6 minus 5 is 25 by 2 minus 5 by 2, which gives us, this is going to be 1. So 1 by 6 minus 1 is going to be minus 5 by 6 minus, and if we evaluate this, we get minus 35 by 6, which gives us minus 40 by 6, which becomes minus 20 by 3. Now area 2 would be integral from minus 5 to minus 1 of minus x by 2 plus 3 dx. So let's evaluate the integral. Minus x square by 2. 2 is already there, so 4 plus 3x from minus 5 to minus 1. So this would be minus 1 by 4 minus 3. This is the first part. Minus, this would be minus 25 by 4 and minus 15. This would be 4 3 is 12, so minus 13 by 4. This whole thing can be converted into plus. 15 4 60, 60 plus 25 is 85 by 4, which gives us 72 by 4, which is nothing but 18. Now remember here, G is greater. So required area would be G of x minus f of x, or rather minus 5 to minus 1, minus 5 to minus 1, dx is equal to 18 minus and minus 20 by 3. So minus 20 by 3, which gives us 18 plus 20 by 3, which is 18 3 is 54 plus 20 by 3, which gives us 74 by 3. This is the required area. Fifth one, of x is equal to 3 by x square, and g of x is equal to 3 in the interval 1 comma 4. Okay, now do they intersect each other? So again, how do we figure out? 3 by x square is equal to 3, so 3 cancels, 1 is there, so we can say x cube is equal to 1. So x is equal to 1, right? Now that is an end point, so within the interval they do not cross each other. Okay, now which is higher? So let's take a value in this interval, let's say 2. So f of 2 would be 3 by 4, and g of 2 would be 3. So which means this f of x would always be a fraction, and this will always be 3. So which means this is higher. Okay, so area 1 is equal to integral from 1 to 4 of 3 by x square dx, which gives us 3 times x to the power of minus 2 plus 1. Okay, this would be minus 1 by x from 1 to 4. Okay, doing the substitutions, we get minus 1 by 4 minus 1 by 1. This gives us minus 3 by 4 plus 3, which gives us 4 3 is 12, 12 minus 3 is 9, so 9 by 4. The second area under the curve is going to be integral 1 to 4 of 3 dx, which is equal to 3 times x from 1 to 4, which gives us 3, 4 minus 1, which gives us 3 3 is 9. Okay, so required area would be what? That would be, which is higher? G is higher. So G is this. So 9 minus 9 by 4, which gives us 9 4 is 36. That is going to be 27 by 4. So that is the area between the two curves. Let's look at the sixth one. F of x is equal to minus 2x square plus 12x minus 19. G of x is equal to minus x square plus 6x minus 5 in the interval 2 to 4. Okay, now let's see whether they intersect each other. Minus 2x square plus 12x minus 19 is equal to minus x square plus 6x minus 5, which implies minus x square plus 6x minus 14 equal to 0, which can be written as x square minus 6x plus 14 equal to 0. And now let's see square root of b square minus 4ac. What does it come to? So square root of b square is 36 minus 4ac. So 14 fourths 56. And this again is going to be imaginary numbers. So that means they do not intersect each other, let's say in the real world. Okay, so that they don't intersect. Now, the second thing we have to figure out is which is higher. Okay, so let's pick a value in between these two. So let's say 3. So f of 3 is equal to minus 2, 9 plus 12 times 3 minus 19, which gives us minus 18 plus 36 minus 19, which gives us 9 plus 8, 17, 137 plus 36, which is minus 1. What about g of 3? That gives us minus 9 plus 18 minus 5. Minus 9 minus 5 is minus 14 plus 18, which is plus 4. So G is higher. Okay. So we have got this information. So area 1 is equal to integral from 2 to 4 of minus 2x square plus 12x minus 19 dx. Okay. So now minus 2 x cube by 3 plus 12x square by 2 minus 19x from 2 to 4. Let's simplify this to 6. And now let's do the substitutions. Minus 2 by 3 times 4, 4, 16, 4, 64 plus 6 times 4, 4, 16 minus 19 times 4 minus, and we have to substitute 2. So minus 2 by 3 times 2 cube is 8 plus 6 times 4 minus 19 times 2. Okay. Now if we evaluate all these, what we get is minus 10 by 3. I will leave it up to you. Okay. Now the second area, A2. Integral from 2 to 4 of minus x square plus 6x minus 5 dx, which gives us minus x cube by 3 plus 6x square by 2 minus 5x from 2 to 4. 2 threes. Now let's again do the substitutions. Minus 64 by 3 plus 4, 4, 16, 16 threes, 48 minus 20. Okay, minus, now let's substitute 2. So minus 2 cube is 8 by 3 plus 4 3 is 12 minus 10. And again, if we evaluate all these things, we get 22 by 3. So, which is higher? Where did we do that? G of x is higher. So that means required area is equal to 22 by 3 minus, what is the other one? Minus 10 by 3, which gives us 22 plus 10 by 3, which is 32 by 3 square units. Seventh one. Okay, f of x is equal to x square by 2 plus x plus 3 by 2. G of x is equal to 2x plus 3 in the interval minus 4 to minus 1. Again, first thing we have to figure out is whether they intersect each other. So x square by 2 plus x plus 3 by 2 is equal to 2x plus 3. Okay, so x square by 2 plus x minus 2x is going to be minus x plus 3 by 2 minus 3 is going to be minus 3 by 2 equal to 0. This can be written as x square minus 2x minus 3 equal to 0. And let's factor out this. xx, and what do we get here? 3 ones. So minus 3 plus 1 is minus 2, and minus 3 times 1 is minus 3 equal to 0, which implies x equal to minus 1 and 3. So what this basically tells us is these are the 2 points or x values at which the curves intersect each other. There are 2 intersections actually between these 2 curves. But important thing is minus 1 is at the boundary, so we don't have to bother about it. 3 is outside this, minus 4, minus 1. So again we don't have to bother about it. Since these 2 points are not relevant, let's make them relevant. So let's make this interval minus 4 to 1 so that we can actually see what is happening here. So, which means our interval minus 4 to 1 will become, or will split it into 2 intervals. Minus 4 to minus 1, and from minus 1 to 3. But remember, our domain itself is up to 1. So, which means this need not be 3. It will be up to 1. Is this clear? Okay. So, now let's pick a value here, and let's pick a value here. Let's pick 0 here. And here let's pick minus 2. We need to keep the calculation simple. So f of minus 2 is going to be x square by 2. So minus 2 square is 4 by 2 minus 2 plus 3 by 2. This is going to be 2 2's. So 2 minus 2 is 0. So 3 by 2. Now g of minus 2 is equal to 2 times minus 2 plus 3, which is minus 4 plus 3, which is minus 1. So here this is higher in the first interval. Now f of 0 is going to be 3 by 2. G of 0 is equal to 3. So which means this is higher. Now why we require this higher and lower business is because we have to do the subtractions properly. Okay. Now let's do the evaluations. So area 1, this is higher. So we have to be careful. Interval, what is the first interval of this? This is higher. So x square by 2 plus x plus 3 by 2 minus, from this we have to subtract the area under the curve of the second one. So that is going to be 2x plus 3 dx. From where to where? From minus 4 to minus 1. And to this we have to add the area after the intersection. So that is going to be minus 1 to 1. And here this is g is higher. So 2x plus 3 minus x square by 2 plus x plus 3 by 2. See, once you are able to write this, then it's just doing the integration and the algebra part of it. So first let's simplify this. X square by 2 minus 2, x square by 2 plus x minus 2x is going to be minus x. 3 by 2 minus 3 is minus 3 by 2 dx, plus minus 1 to 1 minus x square by 2. 2x minus x is going to be plus x. 3 minus 3 by 2 is going to be plus 3 by 2 dx. Let's do the integration. x cube by 3. 2 is already there, so 6 minus x square by 2 minus 3 by 2x from minus 4 to minus 1 plus minus x cube by 6 plus x square by 2 plus 3 by 2x from minus 1 to 1. And now it's just a question of substituting it. So what do we get? We get minus 1 by 6 minus 1 by 2 plus 3 by 2 minus 64 minus 64 by 6 minus 16 by 2 plus 12 by 2. That is the first part. Now the second part. So this would be minus 1 by 6 plus 1 by 2 plus 3 by 2 minus this would be not x 1 by 6 my plus 1 by 2 minus 3 by 2. Okay, now evaluate it. What do we get? Minus 1 by 6, 3 by 2 minus 1 by 2 is going to be 2 by 2. So that is 1 minus 64 minus 30, 16 3 is 48 plus 2 3 is 12 3 is 36 by 6 plus, and usually this is the part that will take up most of your time. So this becomes 4 by 2, that is 4 by 2, that is 2. So minus 1 plus 12 by 6 minus this will be 1 by 6 minus 1 by no minus 2 by 2, so minus 1 minus 1. Okay, now let's see. 6 5 by 6 minus this would be minus 76 by 6 plus 11 by 6 minus this is going to be minus 5 by 6, so 5 by 6 2 3. Okay, let this be 6 itself, so easier. So 5 plus 76 is 81. 81, 91, 92. 92 plus 5 is 97 by 6. So that is the area under or between these two curves. Let's do the 8th one. F of x is equal to x square plus 8x plus 14, and g of x is equal to x square plus 4x plus 2 in the interval minus 5 minus 2. So first thing we need to figure out is the intersections. So x square plus 8x plus 14 is equal to x square plus 4x plus 2. X square cancels. 8x minus 4x is 4x plus 12 is equal to 0. So 4x equal to minus 12, x equal to minus 3. So this is the value of x for which intersection of these two curves happen. So which means that this we can split it into minus 5 to minus 3 and minus 3 to minus 2. So we have these two intervals. Now we have to figure out whether which of in this interval which curve is higher and which is lower. Similarly for this. So in this case, let's take it as minus 4, and in this case let's take it as minus 2.5. So here f of minus 4 is going to be minus 2 and g of minus 4 is going to be 2. So g is higher. In this interval, f of minus 2.5 will give us 4.25 and g of minus 2.5 will give us minus 1.75. So here this will be higher. So we know this now. So now we can try to figure out the area. So area would be equal to integral minus 5 to minus 3 of x square plus 4x plus 2 minus x square plus 8x plus 14 x plus integral minus 3 to minus 2 of f is higher. So this would be x square plus 8x plus 14 minus x square plus 4x plus 2 dx. Now let's simplify. Minus 5 to minus 3, x square minus x square 0, 4x minus 8x is minus 4x, 2 minus 14 is minus 12 dx, plus integral from minus 3 to minus 2 of x square minus x square 0, 8x minus 4x is 4x, 14 minus 2 is 12. Now let's integrate minus 4x square by 2 minus 12x from minus 5 to minus 3 plus 4x square by 2 plus 12x from minus 3 to minus 2, which gives us 2 2's. So this would be 8 plus 2, which is equal to 10. So this is the area under the or between the two curves in the given interval. Okay, now ninth one, f of x is equal to minus x square minus 8x minus 13. G of x is equal to x square by 2 plus x minus 11 by 2 in the interval minus 6 minus 3. So again first intersections. So minus x square minus 8x minus 13 equal to x square by 2 plus x minus 11 by 2. And if we evaluate this, what we will get is x is equal to minus 5 and minus 1. So our interval minus 6 to minus 3 gets split into minus 6 to minus 5, and from minus 5 to minus 3. Minus 1 is out of this domain. So now let's pick a number from here. So minus 5.5, and let's pick a value here. So let's say minus 4. So if we take these two values, what do we get? F of minus 5.5 will give us minus 0.25. G of minus 5.5 gives us 4.125. So this is higher in this interval. Now here f of minus 4 is equal to 2 and g of minus 4 is equal to minus 3 by 2. So here f is higher. So keeping this in mind, we have to do the integrations. So area is equal to integral from minus 6 to minus 5. Now which one will come first? Whichever is higher. So g will come first. So x square by 2 plus x minus 11 by 2 minus, then f will come, minus x square minus 8x minus 13 dx plus, now the second interval, minus 5 to minus 3, and here now f will come first. So minus x square minus 8x minus 13 minus x square by 2 plus x minus 11 by 2 dx. Okay, now let's simplify. Minus 6 to minus 5, x square by 2 plus x square will give us 3x square by 2 plus 9x plus 15 by 2 dx plus minus 5 to minus 3, and here it will give us minus 3x square by 2 minus 9x minus 15 by 2 dx. Okay, this would be 3x cubed by 3 times 2, 3 cancels, plus 9x square by 2 plus 15 by 2x from minus 6 to minus 5 plus minus 3x cube by 3 times 2, so 3 cancels, minus 9x square by 2 minus 15 by 2x from minus 5 to minus 3. And now if we do the substitutions and simplify it, what we will get is 23 by, so that is the area between the two curves. Let's do the 10th one. F of x is equal to minus x square plus 6x minus 4, and g of x is equal to minus x plus 2 in the interval 0 to 4. Okay, again, first thing we have to figure out is whether they intersect. Minus x square plus 6x minus 4 is equal to minus x plus 2. So minus x square plus 7x minus 6 equal to 0. X square plus 7x, not plus, minus 7x plus 6 equal to 0. And if we factorize this, we'll get x equal to 1 or 6. So these are the two values of x for which the curves will intersect. So which means our interval 0 to 4 will map to 0 to 1 and 1 to 4, because 6 is outside the domain. Okay, so the area would be, okay, before we can calculate the area, we have to figure out which is higher and which is lower in these two intervals. So here let us take uh, 1 by 2, and here let us take 2. F of half would be 3 by 4, and G of half would be 3 by 2. So G is greater in this interval. Similarly, F of 2 is equal to 16 and G of 2 is equal to 0. So F is greater. So which means the area would be, uh, here it is G of, okay, so this area would be integral from 0 to 1 of G of x minus f of x dx plus integral from 1 to 4 of f of x minus g of x dx. So let's do the evaluation. So integral from 0 to 1 of minus x plus 2 minus f of x is minus x square plus 6x minus 4 dx plus integral from 1 to 4 of f of x, that is minus x square plus 6x minus 4 minus x plus 2 dx. Let's simplify 0 to 1 of minus x minus 6x. So let's write minus x square plus first, then minus 7x plus 6 dx plus integral from 1 to 4 of here again we will have minus x square. Here it will be plus x square, minus times minus, minus times plus, and this would be yes, minus x square plus 6x plus x, so plus 7x and then minus 6 dx. And now if we integrate, we get x cube by 3 minus 7x square by 2 plus 6x from 0 to 1 plus minus x cube by 3 plus 7x square by 2 minus 6x from 1 to 4. And if we go about solving all this, what we get is 49 by 3. That is the area between the curves. Okay, so that was the 10th one. 11th one. F of x is equal to minus x square by 2 minus 4x minus 7, and g of x is equal to minus x square minus 4x plus 1 in the interval minus 5 minus 2. Again intersections, minus x square by 2 minus 4x minus 7 is equal to minus x square minus 4x plus 1. Okay, so minus 4x cancels, minus x square by 2 plus x square by 2 will give us x square by 2. Minus 7 minus 1 will give us minus 8 is equal to 0. So x square minus 16 equal to 0. X square is equal to 16. X equal to plus or minus 4. Now here plus 4 is irrelevant because it is outside the domain. So therefore minus 5 minus 2 will get split into minus 5 to minus 4 and minus 4 to minus 2. Okay. So now we have to figure out greater or higher or lower, right, the curves. So here let us take minus 9 by 2, right? That is 4.5. And here let us take minus 3. So f of minus 9 by 2 is equal to 0.875 and g of minus 9 by 2 is equal to minus 1.25. So here this is higher. Now f of minus 3 is equal to 0.5 and g of minus 3 is equal to 4. So which means that this is higher. Now once we know that, then it becomes easy. So area is equal to integral from minus 5 to minus 4 of f. So f is minus x square by 2 minus 4x minus 7, then minus g of x, that is minus x square minus 4x plus 1 dx plus integral from minus 4 to minus 2 of, now g of x is higher, so which means minus x square minus 4x plus 1 minus x square by 2 minus 4x minus 7 dx. Okay, now let's simplify. Minus 5 to minus 4 or now minus x square by 2 plus x square. 2x square minus x square. So x square by 2 minus plus. So x will disappear. Minus 7 plus 1 is minus 6. Minus 7, no, minus 1. Minus 1. So minus 8. So x square by 2 minus 8 dx plus from minus 4 to minus 2, and here it will be minus x square plus x square by 2. So this would be minus x square by 2 plus 8 dx. If we integrate, we get x cubed by 6 minus 8x from minus 5 to minus 4 plus minus x cubed by 6 plus 8x from minus 4 to minus 2. And if we solve all this, we get 53 by 6. 12th one. X square plus 2x minus 3. G of x is equal to x minus 1 in the interval minus 4 comma 1. So first let's figure out the intersections. So x square plus 2x minus 3 is equal to x minus 1. So x square plus x minus 2 equal to 0. So which means x is equal to minus 2 and 1. 1 is the boundary. So only minus 2 is applicable here. So minus 4 comma 1 gets split into minus 4 to minus 2 and from minus 2 to 1. Now let's here take minus 3 and here let's take 0. So f of minus 3 is equal to 0 and g of minus 3 is equal to minus 4. F of 0 is equal to minus 3 and g of 0 is equal to minus 1. So here this is higher and here this is higher. So which means the area between the two curves would be integral from minus 4 to minus 2 of x square plus 2x minus 3 minus x minus 1 dx plus integral from minus 2 to 1 of x minus 1 minus x square plus 2x minus 3 dx. So here let's simplify it further. Minus 2 x square as it is, 2x minus x is plus x, minus 3 plus 1 is minus 2x. Integral from minus 2 to 1, and here we will have minus x square minus x plus 2 dx. Okay, now integrating it, we get x cubed by 3 plus x square by 2 minus 2x from minus 4 to minus 2 plus minus x cubed by 3 minus x square by 2 plus 2x from minus 2 to 1. Okay, if we do the substitutions and uh, you know algebra part of it, what we end up with is 79 by 6. So that is the area between the two curves in the given interval. Okay, 13th one. Now let's change gears. Uh, f of x is equal to 2 cos x and g of x is equal to minus 2 cos x. And we have to figure out the area between the two curves in the interval 0 to 5 pi by 6. As usual, we have to first figure out whether they intersect each other. So 2 cos x is equal to minus 2 cos x. 2 and 2 cancel, so cos x plus cos x equal to 0. 2 cos x equal to 0, which means cos x equal to 0, which means x is equal to pi by 2 and 3 pi by 2. Okay. Now, which means our interval 0, comma 5 pi by 6 gets split into two parts, 0 to pi by 2 and from pi by 2 to 5 pi by 6, because 3 pi by 2 is not in the domain. And again, let's pick a value between these two. So let's pick pi by 4, and here let's pick 2 pi by 3. So f pi by 4 is equal to, and if we use the calculator, we know 1.41. G of pi by 4 is equal to minus 1.41. So that means this is higher. Similarly, f2 pi by 3 is equal to minus 1, and g2 pi by 3 is equal to 1. So here this is higher. So the area between the curves would be integral from 0 to pi by 2 of 2 cos x, that is f, minus 2 cos x, that is g, dx, plus integral from pi by 2 to 5 pi by 6 of minus 2 cos x minus 2 cos x dx. Okay. Now, let's simplify 0 to pi by 2. 2 plus 2, 4. So 4 we can take it out. Cos x dx. Plus again pi by 2 to 5 pi by 6 minus 4 cos x dx. Okay, so 4. Let's integrate. What do we get? We get sin x from 0 to pi by 2 minus 4, not integral, sin x from pi by 2 to 5 pi by 6. Okay. So 4 sin pi by 2 minus sin 0 minus 4 sin 5 pi by 6 minus sin pi by 2. So 4 sin pi by 2 is 1, sin 0 is 0, minus 4 sin pi by 5 pi by 6 is 0.5, that is 1 by 2, minus sin pi by 2 is 1. So this becomes 4, this becomes minus 2 plus 4. So this gives us 4 minus 2, 2, 2 plus 4 is 6. 6 square units is the area between the two curves. 14th one, f of x is equal to minus 2 cos x and g of x is equal to cos x. In the previous example, it was 2 cos x. And interval is also different, minus pi to pi by 2. So again, the first thing we do is check for intersections. 2 cos x is equal to cos x, which means minus 3 cos x equal to 0. That means cos x equal to 0. And when will cos x be 0? When x is equal to minus pi by 2 and pi by 2. Now out of this is the boundary. So we can ignore. So we have one intersection within the given interval. So which means our minus pi to pi by 2 gets split into minus pi to pi by minus pi by 2 and minus pi by 2 to pi by 2. Now let's figure out, take a point in between these two. So let's say minus 5 pi by 6. And in this case, let's take 0. So f of minus 5 pi by 6 is equal to 1.732, that is root 3. And g of minus 5 pi by 6 is equal to minus 0.866. So this is higher. Okay, f of 0 is equal to minus 2 and g of 0 is equal to 1. So this is higher. So now we have the information we require. So area would be equal to integral from minus pi to minus pi by 2 of, which is higher, f is higher. So minus 2 cos x minus cos x dx plus integral from minus pi by 2 to pi by 2. Now here g is higher. So cos x minus minus 2 cos x dx. Let's evaluate this. What do we get? Let's first simplify it. Minus pi to minus pi by 2 of minus we take it out, 3 we take it out, cos x dx. And now here inside it is all plus, so plus 3 integral minus pi by 2 to pi by 2 of cos x dx. So this would be minus 3 times sin x from minus pi to minus pi by 2 plus 3 times sin x from minus pi by 2 to pi by 2 minus 3 times sin minus pi by 2 minus sin minus pi plus 3 times sin pi by 2 minus sin minus pi by 2, which gives us minus 3 sin minus pi by 2 can be written as minus sin pi by 2. This again can be written as minus, we can take it out. So plus sin pi plus 3 times sin pi by 2 is, uh, let's write it as it is, sin pi by 2 plus sin pi by, which gives us minus 3 times. Now sin pi by 2 is 1. So minus 1 plus sin pi is 0 plus 3 times sin pi by 2 is 1 plus sin pi by 2 is 1. So we get 3 plus 6, which is 9 square units, is the area between these two curves in the given interval. Okay, 15th one. F of x is equal to sin x and g of x is equal to minus 2 sin x in the interval minus pi to pi by 2. Okay, again intersection sin x is equal to minus 2 sin x, which makes it 3 sin x equal to 0. Sin x equal to 0, that means x equal to what? Minus pi and 0. Minus pi is the boundary, so we can ignore it. So we have 0. So our interval minus pi to pi by 2 gets split into minus pi to 0 and from 0 to pi by 2. Okay, now let's pick a value in here in this interval. So let's say minus pi by, and here let's pick pi by 4. So what will f of minus pi by 2 be? F of minus pi by 2 is equal to sin minus pi by 2, which makes it minus sin pi by 2. So sin pi by 2 is 1. G of minus pi by 2 is equal to, again, minus 1 times minus 2. So that is 2. So this would be higher. In the second interval, f of pi by 4 is equal to sine pi by 4. Now sine pi by 4 is 0, 1, 2. So that would be 1 by root 2. G of pi by 4 is equal to minus 2 times 1 by root 2. Right? So this is a negative term. So this will be higher. Okay. So we have everything we need. So area is equal to minus pi to 0 of minus 2 sine x minus sine x dx plus integral from 0 to pi by 2 of sine x minus 2 sine x. Okay. So now minus pi to 0 of minus 3 sine x dx. This again inside is plus, so plus 3 integral from 0 to pi by 2 of sine x dx. Okay, now let's integrate this. Minus cos x from minus pi to 0 plus 3 times minus cos x from 0 to pi by 2. Minus we can take it out, so this becomes 3. Cos 0 is 1 minus cos minus pi to be minus 1 plus 3 times. Okay, let's take the minus sign out. Minus 3 cos pi by 2 is 0. Minus cos 0 is 1. So what do we end up with? 3 times 2 minus or plus 3, which gives us 6 plus 3, 9 square units. So that is the area between the two curves in the given interval. 16th one, f of x is equal to minus 2 sine x. G of x is equal to 2 sine x in the interval minus pi to pi by 3. Okay, intersections. So 2 sine x is equal to minus 2 sine x, which gives us 2 sine x plus 2 sine x. So 4 sine x is equal to 0. Sine x equal to 0, which means x is equal to, in this interval, minus pi and 0. Minus pi is the boundary, so we can ignore it. So our interval becomes minus pi to pi by 3 gets split into minus pi to 0 and 0 to pi by 3. Okay. Now here let's pick a value. So let's say minus pi by 2. Here let's pick a value. Let us say pi by 6. So f of minus pi by 2 will be equal to 2. G of minus pi by 2 would be equal to minus 2. So here this is greater. Now f of pi by 6 would be equal to minus 1 and g of pi by 6 would be equal to 1. So in this case, this would be higher. Okay, now we have all the information. Area is equal to integral from, what is the intervals? Minus pi to 0 of f is greater. So minus 2 sine x minus 2 sine x plus integral from 0 to pi by 3 of Now in this case g of x is higher, so which means this would be 2 sine x minus 2 sine x, so plus 2 sine x dx. Okay, so this becomes integral from minus pi to 0 of minus 4 sine x dx plus 4 integral from 0 to pi by 3 of sine x dx, which gives us minus 4, and if we integrate it we get minus cos x from minus pi to 0 plus 4 times uh, minus cos x from 0 to pi by 3. Okay, now let's take minus out, so this becomes 4. Cos 0 is 1 minus cos minus pi is going to be minus 1. So minus 1 plus 4. Again, we can take this minus out. So we end up with cos pi by 3. Cos pi by 3 is not pi, 1 by 2 minus, here we have taken it out. So this will be minus. So this will be minus and this will be 1. So what do we have? 4 times 2 minus 4 times minus half, which gives us 8 plus 2, which is 10 square units. Okay, 17th one. And now let's change gears again. F of x is equal to e to the power of x and g of x is equal to e to the power of minus x in the interval minus 1 to 2. So we have to figure out the area between these two curves in this interval. Again, intersection, so e to the power of x is equal to e to the power of minus x, which implies e to the power of x minus e to the power of minus x is equal to 0, which implies e to the power of x minus 1 by e to the power of x equal to 0, which implies e to the power of 2x minus 1 equal to 0, which implies e to the power of 2x equal to 1. Now we have to take care of e. So ln of e to the power of 2x is equal to ln of 1, which implies 2x equal to 0, which implies x equal to 0. So this is where the intersection is. Okay, so which means our interval minus 1 to 2 gets split into minus 1 to 0 and 0 to 2. Okay, now let's pick a value here. So let's pick minus half and let's pick a value here and let's pick up 1. So f of minus half will be e to the power of minus half, and g of half is equal to e to the power of minus half, so plus half. So this is positive, this is negative, so this is going to be higher. Okay, so f of 1 is equal to e to the power of 1, which is equal to e. G of 1 is equal to e to the power of minus 1, which is 1 by e, which is equal to a smaller number than e, right? So we don't have to do this. So in this case, this is going to be higher. So therefore, area would be integral from minus 1 to 0 of e to the power of minus x minus e to the power of x dx plus integral from 0 to 2 of e to the power of x minus e to the power of minus x dx. Okay, now let's integrate. Minus e to the power of minus x minus e to the power of x from minus 1 to 0 plus e to the power of x plus minus minus, so plus e to the power of minus x from 0 to this would become minus e to the power of 0 minus e to the power of 0 minus minus e to the power of 1, yes, minus e to the power of minus 1 plus e to the power of 2 plus e to the power of minus 2 minus e to the power of 0 plus e to the power of 0. This gives us minus 1 minus 1 minus minus e minus 1 by e plus e square plus e to the power of minus 2 minus 1 plus 1, that is 2. Okay, so here also we have minus 2 plus e square minus 1 plus 1 by plus e square square plus 1 by e square minus 2. So finally the area between the curves would be e square plus 1 by e plus e to the power of 4 plus 1 by e minus 4. And finally 18th one, f of x is equal to x square and g of x is equal to square root of x in the interval 0 to 1. Again we have to figure out the intersections. So x square is equal to square root of x, which implies what? That x would be either 0 or it will be 1. Okay, so which means 0 is on the boundary, so no need, 1 is on the boundary, so no need. So that means we don't have to bother about splitting this interval, which is higher. So it may look as if this is going to be x square is going to be greater, but still let's take a value. So let's say f of half is going to be 1 by 2 square, which is 1 by 4. G of half is going to be square root of 1 by 2, which is equal to 1 by square root of 2. This is 0.25 and this is going to be 0.707. So even though it looks as if this is going to be greater, but actually square root of square root of x is greater. That is in this particular interval. Okay. So now, which means area between these two curves in the given interval is going to be from 0 to 1 of square root of x minus x square dx. Now let's integrate x 1 by 2 plus 1 is 3 by 2 by 3 by 2, which can be written as 2 by 3 minus this is going to be x cubed by 3 from 0 to 1. So now we have, let's do the substitutions. 2 by 3 minus 1 by 3, yes, 0 minus 0, which is equal to 2 by 3 minus 1 by 3 is 1 by 3. This is 0. So this is the area between the two curves in the given interval. So that was area between the curves. That's it.